page 11. Page 11. I was going to write that there. Oh, yep, there it goes. Page 11. It says it at the bottom. Page 11. I just wrote it at the top, so you know. It should say week 3, individual lesson. Insane. So you should be watching this when you're not in the classroom and in the math classroom, and then you're going to have some practice. So this should be kind of a review today, a little bit. Okay, so today we're going to be solving inequalities. Okay, and that's just about finding values of variables. So very similar to what we did with solving equations, which should be why it kind of feels like review, okay, to make true inequalities. True just means that it actually works, okay? Yep. Okay, so an inequality is just a way to compare two amounts. So instead of saying that they're equal, and sometimes we do say they're equal, it's just a way to say, okay, this one's greater, this one's less, comparing, okay? Who has more, who has less, who did better, who did worse, things like that. Okay, so just as a review, this sign, when it opens up to the left, so the side that has that space is on the left side, this is a greater than. So when we name this, we would name this as greater than. So we're looking for numbers bigger. Okay, when it goes the other way, okay, when it opens up to the right, this is a less than sign. So smaller. Okay. Now the only difference between these two, this greater than one and this one below, is this line. That line is actually the bottom line of an equal sign. Okay, it's like if we did a greater than and an equal, and then we just pop that right there, greater than or equal to. That means it could be the same number. It could be equal. So greater than, and it's with an A because we're comparing, greater than or, that's not an O, or equal to. Okay. This one goes the other direction, so it's very similar. It just has that line underneath, which means they added on that equal sign, but they just plopped that less than sign on top. So this is going to be less than or equal to. So to get a on a test, you have to have a greater than or equal to score of 90%. Okay, meaning if you have 90%, you do get the A, or if you have a number greater. Now when you graph these on a number line is a line that goes across, it has the numbers. We need boundaries, and so this one's going to be open because it doesn't have that equal to. It says everything up to that point, and same thing with less than. When they have that equal to, greater than or equal to, when we do that circle, it's going to be closed, and here it would be closed. So we shaded in. That's really important. And we're going to explain that on the next page, or I'm going to explain that on the next page, but that's a really important part of inequalities when we graph. Okay. All right, one really big part of solving inequalities is the multiplication and division inequality property, which says when you multiply or divide, both sides of an inequality by a negative, you must flip the inequality. Okay. So for example, these ones are just the one-step inequalities. We're not going to do them on the back page because we're just going to go straight to two-step. To undo multiplying by -2, remember the inverse of multiply is divide. Inverse of add is subtract, and vice versa. Inverse of subtract is add. Inverse of divide is multiply. So to undo multiplying by -2, we would divide by -2. And if we do it on one side, we do it on the other side. So since I'm dividing both sides by negative, when I write my answer, I get x. 8 divided by -2. 8 divided by 2 is 4. Positive divided by negative is a negative. So since this went from a positive to a negative, it went to the opposite, I have to do the opposite sign. So instead of greater than, it's now going to flip around and be a less than. Okay, same thing with dividing. We don't see this a lot, but it would be the same idea. This is dividing by -5. So to undo dividing by -5, we multiply both sides by -5. That was a weird 5. Pretend that looks nice. Okay, that undoes the -5, so we're left with just x. And then -1 times -5. A negative times a negative is a positive, so +5. And this would switch from a less than or equal to a greater than or equal to. Okay. All right, so we just have 4 examples. This should feel really familiar on how we do it until the graph. Because how we solve it is just like last week with us solving equations. Okay, so here's our x. We want to get that x by itself. It's chilling out with that 9. So we would get rid of this adding 7 first. So to undo adding, remember inverse of add is subtract. Inverse of multiply is divide, and vice versa. Vice versa means the other way too. That's why we have 2 arrows. So divide is multiply, subtract is add. So to undo adding 7, we would do -7 on both sides. Okay, that 7 is now not there because it's a 0. So I have 9x. I'm going to keep that less than sign right now because we didn't divide by anything or multiply, so no worries. -92 minus 7. We can use that Desmos calculator. We get -99. Okay, remember this means to multiply, so if it helps to sneak in a little multiplication sign there, do that. Okay, to undo multiply, we divide. Now here's the question, are we dividing by a negative? No, I'm dividing by a positive. So I'm not going to flip that sign. I don't need to worry about it. So I have x is less than -99 divided by 9, -11. So x is less than -11. All right, so on a number line, we're going to put that number, whatever, when the value, when the variable is isolated, that number is going to go near the middle. It doesn't have to be the exact middle. I don't know which one is the exact middle, so I'm just going to pick this one, -11. Okay, and then we're going to label the other lines. Now, normally, if it was positive, it'd go 11, 12, 13. But we're doing negatives, which are opposites. So instead of counting up here, which we are counting up, but it's going to go -10, -9, -8. Now, if making number lines is hard for you or just challenging, or you've just never done it before, in the back of your notes, that wasn't the right thing to say, ignore that, in those colored papers, so you should either have green or purple colors, okay, you should have the very last page, there's a number line thing like this, okay. So we're doing -11, and so we could just want it to look exactly like this. So -11 is near the middle, and then to the right goes -10, -9, -8, -7, -6, and then on the other side goes -12, -13, -14, 15. So we can just take this right where it is and just copy that as long as that -11 is somewhere near the middle. Okay, it's just a less than sign. So with just less than, that was an open circle because it does not include. So we're going to circle the tick mark at -11, but we want it to be open. So you have to be able to see the inside. Now I want numbers smaller than -11. This might be another way that's nicer to use your number line in that back of those colored papers. Okay, here's -11, and I want numbers smaller than that. So does that mean okay, that doesn't work. Does that mean all of these numbers to the right are smaller, or all the numbers to the left? Sometimes that's hard when we look at it just at this number line because our brains are like, oh, 10 is smaller than 11. But -10 is actually bigger. And I know that because if I look way past negative 11, I get to like 13, 14, 15. These positives are definitely greater than negative 11. So to actually go smaller or less than, we're going to go to the left. Okay, so to do that, we just make this nice line on top like that with an arrow saying it's going to go on forever. So that includes negative 17, negative 18, negative 19, negative 20. Okay, if you had me last year, we also do the scribblies. So you could go scribble, 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 scribble. Okay, I like to do scribblies, so I'm going to do that the rest of the time because they're fun. All right, now we're just going to go into a few different types of the different things that you see when we solve inequalities, and they're the different things that we saw when we solved equations. So here we have parentheses, negative 2 times the quantity of 5n plus 1 minus 8 is less than negative 90. So first thing here we'd have to do is distribute. Pew, pew. So we're going to do negative 2 times 5n and negative 2 times 1. Okay, if you don't need to write that, that's okay. I'm just showing that for people to see what we're thinking. Okay, negative 2 times 5, a negative times a positive is a negative, and 2 times 5 is 10. So negative 10n plus negative 2 times 1, anything times 1 is itself, so negative 2. And then this minus 8 is less than negative 90. Okay, I have 3 parts here. Normally when we have 3 parts, that generally means 3 parts, only 1 variable. We need to combine something. So we're going to combine the negative 2 and negative 8 because those do not have variables. They're just numbers. Okay, and we can use Desmos. Negative 2 minus 8 is negative 10. So this is actually going to be negative 10 here. Seriously, dudes? Okay, so we get negative 10n plus negative 10 is less than negative 90. Every time I'm rewriting that inequality. The only time I'm going to switch it is if I multiply or divide both sides by a negative number. Okay, so this negative 10 is chilling with an n. We get rid of adding negative 10. Inverse of adding a negative is adding a positive. So add 10, add 10. Negative 90 plus 10 is going to be negative 80. Keep that less than sign because there's no multiplying or dividing. Negative 10n is less than negative 80. Now to undo multiplying by negative 10, we are going to divide by negative 10. So you can use that division sign like we did in number 1, or you can use that fraction line. So negative 10, negative 10. Now this is where we're like, ooh, ooh, pew, 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 pew. That's a car alarm sound in case you're wondering. Okay, we divided both sides by negative here. It says divide by negative 10. Okay, that means we have to switch our inequality. It's going to go from a less than to a greater than. That's the big difference between equations and inequalities, as long and with graphing and 20 million other reasons. But we're going to do negative 80 divided by negative 10. Okay, and we get a positive 8. So n is greater than positive 8. So in our number line, that's the boundary. That's where it begins or where it ends. Okay, so that's going to go near the middle. Now this one might be easier for you because 8, 9, 10. If you need to look at your number line on that paper, we're going to go to positive 8. So ours should look just like this. 8 in the middle, 9, 10, 11, and to the left would be 7, 6, 5. Okay? So 8, 9, 10, 11, 12, 13, 7, 6, 5, 4, 3. Okay? It's a greater than sign, so without that equal to, that means it's an open circle. And I want numbers bigger. So this is greater than means bigger, so I'm going to go to 9, 10, 11. So you can do that line that we did for number 1 where it goes up above, or you can just scribble right on the line and then fill in that little arrow saying it's going to keep going on and on and on and on and on. What that means is any of those numbers would work for x, but not x because it's an n. You know. All right. Number 3, if you want to pause here and do some of the practice work, you could, because this one is a little different. We have an M there, and whoa, it's on the other side too. Crazy. So we want to get them on the same side. Most students like the variable on the left side when we do inequalities because the graphing is easier to work with. But you could get rid of either one. It's up to you. I'm going to get rid of that 8m, or undo the 8m. So to undo adding 8, we do a minus 8m. When I did that on the left side, I'm going to put it right underneath the 6m. So I'm going to say minus 8m. Okay, and we're just doing the coefficients. 6 minus 8. I can think about that as 8 minus 6, which is 2, but we did the smaller minus bigger, so it's negative. So negative 2m minus 11 is greater than or equal to 1. No multiplying or dividing happened, so it stays the same. Okay, to get rid of a subtracting 11, because negative 2 is like best friends, they're chilling, they're hanging, we're going to let them be for a second. We're going to get rid of this minus 11. So we're going to add 11 to both sides. So now we have negative 2m is greater than or equal to 1 plus 11 is 12. I don't know why I said it that way. All right, last step, we have to undo this multiplying by negative 2. So we're going to divide both sides by negative 2, and I am running out of space. Who the heck made these notes? Just kidding, I did. Okay, so when I divide by negative 2, that gets rid of that. So I'm left with just m. 12 divided by negative 2, positive divided by negative is a negative, and 12 divided by 2 is 6. Now to decide, do I need to flip my inequality? Should it go the other way, or should it stay the same? Did I divide by a negative? That's really the question we're asking. Yes, I divided by negative 2. It doesn't matter what number's up here, it's what did we do on both sides. We did both sides negative 2, so it needs to flip. So instead of going this way, a greater than sign, we need a less than sign, or equal to. Okay, so negative 6 is our boundary. That's going to go near the middle. I don't know if that's the exact middle. And then if you'd like to, you can use that number line on the back. Here's negative 6. So yours should look exactly like this pretty much. So go negative 6, negative 5, negative 4. So negative 6, negative 5. So we always want numbers on the right side too. Technically, they're bigger. What is happening? I don't know. Negative 5, negative 4, negative 3, negative 2, negative 1. So that means on the other side would be negative 7, negative 6. Nope, not 6, negative 8. I was totally making an 8 there. Negative 9, negative 10, negative 11. Now it has this equal to. So when it has that equal to, when we do our circle, it is closed. So when we circle, we're going to close it and shade it in because it includes. So I'm going to circle the negative 6 and I'm going to close it. Okay, and I want numbers smaller than negative 6. So if I think to that number line, here's negative 6. Are all of these numbers smaller, or are all of these numbers smaller? And I know for a fact that 0 is bigger than negative 6, or like 1, 2, 3, 4, 5, 6. I know that 20 over here is bigger. So if I want numbers smaller, I can't go that direction. I have to go the other direction. So I'm going to go to the left. I like the scribbling because it's more fun. Let's be real. Sometimes math isn't that fun. Just kidding. Math is always fun. If Miss Fisher asks if I ever said math is boring, don't tell her I said that. Because I didn't. I kind of did. Okay, last one. This one's going to be a little, I don't know, you might have trouble fitting it all in, but that's okay. All right, remember this is really like a negative 7 here, that whole thing, so we're going to distribute. Pew, pew. So if you need to write out that we're doing negative 7 times 5c, and then we're going to do negative 7 times 1. That can be helpful. If you don't want to write that, and you can do it in your head, great. Negative 7 times 5, a negative 7 times a positive 5 is going to, negative times positive is negative. 7 times 5 is 35. Really important we keep that c. Negative 7 times positive 1. Negative times a positive 1 is always the same. I don't know what I'm saying anymore. I'm getting a little tired. Okay, plus negative 7 is less than or equal to 32 plus 5c. Nothing's changing over here. Okay, I have a negative 1, and I can combine that with that negative 7. Now, if I had two c's, I would add those c's together, but here I'm just going to add those two constants, which is very similar to number 2. Okay, so negative 1 plus negative 7 is negative 8. So I get negative 8 plus negative 35c is less than or equal to 32 plus 5c. Now it's up to you if you would like to move the 5c over or to the left side, or we can move the negative 35 to the other side. So either we're going to do plus 35c plus 35c, get rid of this c, or we're going to do minus 5c minus 5c. Most students like to do this minus 5c because they like the c on this side or the variable on that side. So I'm just going to do it that way. Okay, so we have negative 8 plus negative 35 minus 5. If that's challenging, that's okay. Negative 35 minus 5 is negative 40. So negative 40c. Okay, didn't multiply or divide by a negative, so it stays less than or equal to, and this is a positive 32. Okay, 40 is the bestie. They're chilling, relaxing. We're going to be for a second. We're going to get rid of this adding a negative 8. To undo adding a negative, we add a positive. So we're going to do plus 8. If we do it on one side, we do it on the other side. I bring down that 40c, negative 40c. Stays the same, less than or equal to 32 plus 8 is positive 40. Okay, hopefully you wrote a little bit smaller than I did, otherwise we're going to go a little bit into the takeaways, and that's okay. We're going to get rid of this multiplying by negative 40, so to undo multiplying by negative 40, we're going to divide. So divide by negative 40, do it on one side, do it on the other side. Okay, beep, 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 bloop, bloop, pew, 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 pew. That's your car alarm noise to let you know that when we divide by a negative, we have to flip this inequality. So because this negative on both sides is I can't talk. This number is both negative, we have to flip. So instead of less than, it's going to be greater than or equal to. And then a positive divided by a negative is a negative, and they're both the same number, so it'll be negative 1. It's okay to use Desmos if you'd like to. Okay, so that's our answer. But it also asked us to graph, so we're graphing on a number line. So I'm going to put that negative 1 near that middle. If I'd like to use my number line to help, I can do that. Okay, here's negative 1, so to the right would be 0, 1, 2, 3. So 0, 1, 2, 3, and then 4, 5. And to the left of negative 1, so right here's negative 1, it would go negative 2, negative 3, negative 4. Okay? Obviously, you don't have to use that sheet if you don't want to, but if it helps, might as well use it. Okay, because it has that equal to means that it's going to be closed. So we're going to circle and close it. Now I want numbers bigger than negative 1. So my question is, are all these numbers to the right bigger than negative 1, or are all the numbers to the left bigger than negative 1? And it's going to be all the numbers to the right, because it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and fill in that little arrow so we know it keeps going on and on and on and on, all the way up to like 5,000. All right, you're going to fill in your takeaways. Your takeaways are going to be like, when do I flip the inequality? When do I have an open boundary? When do I have a closed boundary? Or like you could say, it's pretty much the same as equations. It's up to you, because it's your takeaways. Okay, bye.